All right, so we're going to continue our talk about functions, and you'll see in a second why we took a break and talked about piecewise functions yesterday for a few minutes. Today we're going to talk about something called continuity, and continuity is from the word continuous, and the graph of a continuous function has no breaks, no holes, and no gaps. So you can trace the graph of a continuous function without lifting your pencil. If you look at this graph here, I could trace the entire thing and never pick my pencil up, right? So that's a continuous function. A function that does have breaks, holes, or gaps is called discontinuous. Okay, and that's what we're going to talk about right now, is different types of discontinuity. So the first kind occurs in a graph like this. Now, you may remember the idea of something called an asymptote that runs through here, and it keeps these two parts of this function from ever meeting or ever crossing. Now, anytime you see this, you see one part of the function is increasing to positive infinity, and another part of the function is decreasing to negative infinity. When that occurs, this is called an infinite discontinuity. Here's a second example, or a second type of discontinuity, when you have some kind of function. And remember, when we read a graph, we always go from left to right, because that's how we read a graph. So we always read left to right. So when we look at this function, as we move along the x-axis, we see that this function is decreasing. It's moving along, it's moving along. As we're moving across the x-axis, when we get to this point C, something happens. This function, this portion of it, includes C. This portion does not. So this is a piecewise function where this includes everything up to C, and this includes everything after C, but not C. This kind of discontinuity is called a jump discontinuity. It's almost as if the graph moves along and then it jumps up here and continues. And the last kind of discontinuity is when you have a hole. So you have a function and you can trace it with your pencil and you never have to pick it up until you get to this one little spot. It's just a hole in your graph. So that's called a removable discontinuity. So we're going to do, real quick, a couple examples and determine whether each function is continuous. If it's discontinuous, you identify the type as an infinite, a jump, or removable. So we'll just start with A. On A, I can move my pencil along this function, never pick it up, and I can go from one end of it to the other if I could drag my pencil for infinity. So this is a continuous function. This one here, remember, I'll always go from left to right. So as I move along, I have to stop. And I'm going to have to jump down here and then continue the function. So this is a jump discontinuity. And then when I look at this graph, I can move along from left to right, and I get to here, and what's wrong? I have a little hole, right? So this has a removable discontinuity. But you see, as I get to here, I keep going, I go straight down. And I'm going down to negative infinity. And I'm never ever going to get to the next part of this graph unless I go over to positive infinity and start coming back down. So that is an example of an infinite discontinuity. So this function has both. It has a removable discontinuity and an infinite discontinuity. So something else that we're going to talk about with our graphs and our functions is something called end behavior. Okay, the end behavior of a function describes how the function behaves at either end of the graph. The terms end behavior describe what happens to the values of f of x as x increases or decreases without bound. And that just means forever heading towards positive or negative infinity. So we're going to use a concept from calculus to describe the end behavior of a function, and that concept is called a limit. Okay? And when we're talking about the left end of a graph, and I know we have a picture down here. I don't want you to really look at it yet. I'm just going to draw a quick little picture right here. If I just have a graph, right, looks like this. When I talk about the left end, I'm talking about right here. But this arrow tells me that I really would go on forever. So I'm really not talking about right here. I'm talking about way down here. But as far as the x-axis is concerned, because we're talking about x increasing or x decreasing. So along the x-axis, I'm really talking about way out here, as far as I can go to the left. And as far as I can go to the left is negative infinity. So the way we talk about left end behavior is we say we're interested in the limit as x approaches negative infinity of f of x. And so negative infinity is way out here on the x-axis, right? And actually I should probably not write it there because that might make it confusing. So that's negative infinity. And now when I talk about right end behavior, I'm talking about as far right as I can go on this graph, which would be positive infinity. So right end behavior is talked about as the limit as x approaches positive infinity, and we just put infinity. So it's the limit as x approaches infinity of f of x. So the way we say this is the limit of f of x as x approaches infinity. Notice I left a little space here because you're going to always have to insert whether it's positive or negative infinity. So the way we would say either one of these, the way we'd say the left end behavior is this is the limit of f of x as x approaches negative infinity. For the right end behavior, we're going to say this is the limit of f of x as x approaches positive infinity. Or you could just say infinity and it's understood that it's positive. But for now, let's keep the positive and negatives to make everything straight in our heads. All right, so let's look at this picture down here and kind of get an idea of what all this positive and negative infinity stuff and what we're approaching and what all that means. So let's look at just the x-axis for a minute. So here is the x-axis, and you know that along the x-axis there's values. So there's -1, -2, -3, and we go in this direction. There's 1, 2, 3, right? We could keep going forever, and we list out every number we can think of. But eventually, we would get to infinity. And so what these two arrows here with the x and the negative infinity are saying that as we go farther and farther down the x-axis to the left here in this direction, as we go farther and farther this way in the direction of this arrow, x, this x here, is approaching negative infinity. Eventually, that's what it's going to get to. And on the opposite side, as we continue down this x-axis, as we keep going farther and farther in this direction, our x value on our x-axis will be approaching infinity. So that's what the x approaching infinity or the x approaching negative infinity means. It tells you what the x values are getting closer and closer to. Now let's look at the y-axis exclusively. Just look at the y-axis now. So on the y-axis, you see that it says f of x is approaching infinity, and down here it says f of x is approaching negative infinity. Well, as you move down the y-axis, you're getting lower and lower, right? You start here at -1, -2, -3. Well, when you get all the way down as far as you could go, you're going to be at negative infinity. So f of x, which is really y, is approaching negative infinity. And up here at the top it says f of x is approaching infinity. Well, the higher and higher you go on the y-axis, eventually you're going to get to infinity. And so y is approaching infinity. Now let's put these two together and talk about this graph. So we have this function here, this f of x. It says y equals f of x. So on our function, as our x values get closer and closer to negative infinity, so the farther and farther we get out here on the x-axis, so we get way out here on the x-axis, well, this function is going to increase, and it's going to keep increasing. So it's going to be way up here somewhere. It's going to increase towards positive infinity. So we say the limit of f of x as x approaches negative infinity, so as x is going way out this way, f of x is going to be reaching positive infinity. And so the limit of f of x as x approaches negative infinity equals infinity. And the same is true down here. If we continued out the x-axis just as far as we could go and we got way out here somewhere, well, you can see that our f of x is going down quickly. So when we're way out here, our f of x graph is going to be way down off the computer, off the screen, down real low, all the way down to negative infinity. So the limit of this f of x as x approaches infinity, so as x gets bigger and bigger way out here, the limit of f of x as x approaches infinity equals negative infinity. And I know it may be a little confusing, but we're going to practice it a lot. And if you can make it straight in your head, these are really going to be easy for you. So let's take a look at a couple examples here. So use the graph of each function to describe its end behavior. So we have these graphs and we have this horrible looking function that we're not going to do anything with. We're just going to look at the graph. So down here we see it asks us for the limit of f of x as x approaches infinity. So that means it wants to know what is going on when our x values get way out here somewhere. Well, you can see that our function is decreasing. It's going down towards negative infinity. So as x approaches infinity way out here, f of x is approaching negative infinity. So the limit of f of x as x approaches infinity is negative infinity. And then let's look at the other one. It asks us what's the limit of f of x as x approaches negative infinity. So we're going to go way out this way. Way out to negative infinity. So as we go out to negative infinity, what is our function doing? Well, it's decreasing. It's going down. It's also going down to negative infinity. So the limit of f of x as x approaches negative infinity way out here is also negative infinity way down off the graph. All right, so let's do another one. Here we have a function. It wants to know what's the limit of f of x as x approaches infinity. So as x approaches infinity way out here, well, we see our function is shooting up, right? So as x approaches infinity, our function is going to also be approaching infinity on the y-axis. So the limit of f of x as x approaches infinity is infinity. And we'll look at the left end behavior, which is what this is asking us for. Well, we see that it's going down, right? It's going down towards negative infinity. So the limit of f of x as x approaches negative infinity is negative infinity. So just take some time and try to let that sink in. Don't get too overwhelmed by it. It seems simple, but it can get really confusing. You can get it mixed up in your head really quick. So that's it. See you tomorrow.